Welcome to the lecture. In this lecture, we are going to see the applications of systems of equations. Let us take a mass balance problem. We will consider a series of distillation column. So, let us say, I have a distillation tower in which you have gasoline, kerosene, diesel, fuel oil. These are basically the input flow rates which are passing through the distillation tower. So, they are represented in kg mole per minute. So, when you look at T1, so T1, T2 are basically the top products, B1 and B2 are the bottom products. So, the output flow rates they are given in percentage. So, G for basically for gasoline, K for kerosene, D for diesel and F for fuel oil. So, our input flow rates they are given in kg mole per minute, and the output flow rates from the two distillation columns have been indicated in percentage by mass for the each of the components. So, each of the component in sense, so you have gasoline, kerosene, diesel and fuel oil. So, the main objective is we have to find out the actual flow rates in kg mole per minute. So, let us form a system of equations using this flow rates diagram. So, the first equation will be written in the format of, so for the T1 top product, so we have G gasoline which is 24 percentage, and for the bottom product of B1, so we have 15 percentage of gasoline. For the top product 2, we have gasoline is 18 percentage. For the bottom product B2, we have gasoline 7 percentage. So, now we will write the system of equations. So, this will be 0.24 of T1 plus 0.15 of B1 plus 0.18 of T2 plus 0.07 of B2 which is equal to 75. So, basically input flow rates must be equal to the output flow rates. So, this is for the first one. Similarly, we have to do for the kerosene, diesel and fuel oil. The first equation will be 0.24 of T1 plus 0.15 of B1 plus 0.18 of T2 plus 0.07 of B2 equal to 75. So, second one is 0.65 into T1 plus 0.10 into B1 plus 0.24 into T2 plus 0.04 into B2 equal to 125. Similarly, we have to do for the other ones. So, these are the four sets of equations. Now, we have got the system of equations. It has to be written in the format of Ax is equal to B, right. So, we need to find out the actual output flow rates in kg mole per minute. So, now I have written in the matrix format. So, we have got 4 equations. So, which means we have to find out the 4 unknowns. So, first matrix it will be A will be a 4 cross 4 matrix with the values, and X are the unknowns, T1, B1, T2, B2 are the unknowns, and B these are the constants. So, using this information, now we will create a matrix and we will try to solve this problem. So, we will create a 4 cross 4 matrix. You can give the values for the first row. So, it is 0.24, 0.15, 0.18, 0.07. After the first row, you have to separate with semicolon. Similarly, you can write the values for the second row, third row and fourth row. So, this is our matrix A. Similarly, we need to create a matrix B. We have 4 constants 75, 125, 200 and 100. We wanted in the format of 4 cross 1, which is 4 rows and 1 columns. So, that is why I have used the dot tree, which is basically for the transpose. Now, let us print the matrix which we have created. So, this is our A matrix, it is a 4 cross 4 matrix, and B matrix will be a 4 cross 1 matrix. Let us see how to solve this. So, the command will be np.linalg.solve. So, before calling the np, you have to import the numpy package, import numpy as np. Inside the parenthesis, you have to pass the matrix which you have created. So, A will be a 4 cross 4 matrix and B will be a 4 cross 1 matrix, and you can store it in the variable x. When we print x, so these are the 4 values which we have got. So, first value is 138.70453942. This is for the T1. Similarly, we have got the values for the other ones. Now, we have got the actual output flow rates in kg mole per minute. Hope this session was very useful to you people. Thank you.